So welcome to video 3 of our course B08 on data visualization. Here we're going to look at applying ggplot. So we're going to think about examples of where we can apply ggplot. So we might be looking at a bunch of cases, a small number of cases in this example, and we're comparing them to control data, and maybe we're looking at their infection status to see if a particular immune protein concentration has changed when we've extracted it for these two data sets. So what we want to do here really is think if we have a small data set in particular, is plot the actual observations that we see. So our issue with that is that we often see these bar plots or dynamite plots, as they're sometimes shown, where we're just showing summary data, and this is uninformative. These two data sets, black and white, could be any of these distributions here. So they could be very symmetric, they could be an outlier, they could be multimodal, they could have a very unequal sample size, and we don't know this from the first plot. So that's why these plots are really, really bad and a bad option always. What we want to show is the underlying data as shown by the other plots. So you can see there, yeah. So there's different ways of representing this. So we might have, but if these got paired data, we might find that sure they all increase in the same way, but we might find that that is much more heterogeneous, and that there's some people who, some individuals in this experiment that change and that don't change. So we've no sense of this data of the extent to which it is bimodal, skewed, or nor symmetric, and that's why they're a bad idea. And so what we can do is, what we want to do is plot some example data using ggplot. We're also going to make this data tidy before we read it in, so that it visualizes more effectively. And what we're going to do is visualize some cases and controls like the plot shown here, and look at how the summary data might look as well. So if we did box plots, so you can sort of see that. So you can see there, even a box plot, although effective, it doesn't capture these outliers. So the code to do this is to read in some data set, that we've read as we're calling data. We change the aesthetics to be X, and we have two different groups. So groups refer to the cases and controls that we see down here. So X is the value, so X is the X-axis, and we see the different values that we have there. The jitter width is given there, and that's why they're somewhat spread out. And we've limited the y-axis to 151 to see it effectively. This same data is encoded by these bar plots here. So the bar plots just seem to show that the cases are higher than the controls, but in reality, in this data set, some of the cases are lower, and two are much higher. So that doesn't really give us the full picture on the left-hand plots. So if we're thinking about the summary statistics might be hiding this, we can use ridge plots as well. That will also show this in this particular case. So our cases and controls here, if we did the ridge plot for these, we're just taking the same thing. Our data is read into ggplot. We use a different style here because we're using a pipe here to read our data in, to send our data to ggplot using a dplyr. And then we use the function geom density ridges there with a scale to plot them like we see on the right-hand side. So you can see the full frequency there. Another example that we can look at for this is looking at the number of virus particles per sample, as shown here. So you get a bunch of different values, and we're asked to make a 7-leaf plot with the pseudo-assembly for this data. So if we read the sent data into R and do use the stem function to plot it out, we'll get something like this. So you can see, even though this is a simple plot where we have the first significant digit listed on as the first part of this vertical y-axis here, and then we have 99 and 99 afterwards. This is sorted data. So the first two digits here are correspond to this binning structure of 88 and 89 because they're between 50 and 99. The next bin is for 100 to 149, 150 to 199, and so on. So you see here, for example, 200, indicating that this is the values of two values in that band going from 200 to 250, so 213 and 227 maybe. So this is one way of visualizing different data sets. When we look further, we can do a box plot using the simple base or box plot function. So read our data in, give it a color, limit the y-axis if we want, maybe label the y-axis as well, supplying the number of viruses in this box plot. So you can see there, we've got a very simple numerical summary here, where that down is the same data set. Another example that's more complex is where we have two different groups. So we're calling them labels infected and uninfected. So repeating infected 20 times and repeating uninfected 20 times. And the cases are assigned as the infected and uninfected variables we've defined already, with 20 instances of each. We can send this to ggplot. So here we have our group and cases in our data frame here. So that's the data frame we're reading in. We can jitter these to spread them out and also give them an alpha value, which makes them more transparent. So you see alpha set to 0.3 here. We're adding a backspot as well with some transparency too. We're changing the axis labels as well and adjusting the y-axis limits. So if we do that, you see we get two different distributions of the infected and uninfected here with the original data, but also the boxplot represented there. So that's a good solution to plotting these particular figures because they're relatively unimodal for each. So this video that we'll talk about more in the demonstration video looks at how we can use ggplot to plot data, in particular alternatives to dynamic plots, how can you use layers to do that, and how we can plot things using different types of base or and ggplot graphics.